Hello and welcome to some more maths with Mr. Thompson, and today we're taking a wee look at a statistical element here, and we're looking at whether we can make the call to see if two groups are sufficiently different that we can say they have different values based on our sample back in the population. So up till now we've been saying, well, there's a moderate overlap, so we cannot make the call. There's a large overlap, so we can't make the call. Or there's no overlap, so we're kind of getting an intuitive feel for just by looking at it how close we can decide if it's there or not. As mathematicians, though, we wonder: is there a numerical calculation that we can do to remove this kind of vague, language-based uncertainty? Surely in mathematics there's some numbers we can call upon to help us make the call or not. Well, there is. So let's think about what the kind of relevant factors might be in such a calculation. So we're looking at something called the distance between the mean and the overall visible spread, right? So you take two box plots and you have their means on display. That difference, as shown here in blue, the difference between the medians, so I said means, medians, the closer they are, the smaller that number is, then clearly the more likely the two groups are similar. And the further apart those two are, the bigger that number is, the more likely the two groups are different, right? So that's one thing. Let's take a look at another thing. The way this, remember we're talking about the middle 50% of this data. The spreads of two boxes. How much data is there? What's the width of the mean data? What we're saying is the overall visible spread, the bit in the green, from the higher upper quartile, from the larger box to the lower quartile of the lower value. That's the kind of where the mean data lies. So we're looking to see what kind of value, how close the medians are relative to the bulk of the data, right? What we do is we combine both those things together and we compare the distance between the medians. We don't compare, we involve the distance between the medians and the overall visible spread in a calculation. And we're trying to work out what percentage this is of that, right? And depending on how much that percentage is, we can decide if we're going to make the call or not. So just think about it intuitively. If the distance between medians is big relative to the overall visible spread, in this case, it's about, what we're saying, about 90%, that blue zone compared to the green zone, approximately 20%. Looking at it, the medians are quite far apart. I would say you're more inclined to say, yeah, we can make the call there because it's a large number, a big percentage. In our second example, the medians are very close together. I haven't changed the OVS. The medians are close together. I'd say it's about 10%, shall we say? The distance between that, as a percentage of that, 10%. That number is small compared to that one. So maybe we cannot make the call there, right? So when that number's big, that percentage calculation, that DBM over OVS, we're more inclined to make the call. When it's small, we cannot. However, with any sample, our level of confidence depends on the sample size. So what we do is say, well, if the sample size is about 30, we need that percentage calculation to be more than 33%, right? That number there. This ratio here. For a small sample size, we need that number to be big. But as the sample size gets bigger, we can actually be more confident with a relatively small DBM OVS percentage. So that's the thing, that's the sample size variation. The bigger the sample, the less convincing we need. The smaller the sample, the more convincing we need. Okay. Take a quick look at a quick example. We've got length of hair between girls and boys. I'm saying here the girls' median is 200, the boys is 50. So the difference between the medians is 200 minus 50, which is 150. The overall visible spread has got the upper quartile of this one and the lower quartile of that one, which is 610 minus 10. So the overall visible spread is 600. Now, I've used these numbers for convenience sake, they're not meant to be realistic. So when I do my DBM OVS percentage calculation, I get that as a percentage which handily is 25%, right? Okay. Now, what does that mean? Can we make the call? Well, we have to check the sample size. If the sample size, if n equaled 30 here, then we need that calculation to be more than 33%, and it isn't. 25% isn't going to be enough, so we cannot make the call. However, if we had the same numbers, but in a sample size of, say, 100, well, now we've got much more data. Now we don't need as much convincing. Now we only need that calculation to be more than 20%. And since ours is 25%, it is more than 20, so we can make the call. So that's how we can use a numerical calculation to help decide if we can make the call or not. But please remember, your data is only as good as your sample. We're trying to see if the sample can tell us something about what's happening back in the population. So the sample size is going to affect our level of confidence.